The Swift language. In this chapter, you are going to focus on the basics of Swift. You will not learn everything, but you will learn enough to get started. Types in Swift. Swift types can be arranged into three basic groups: structures, enumerations, and classes. Its structures and enumerations are significantly more powerful than in most languages. All of these Swift types are structures, such as numbers, booleans, tags, and collections. This means that the standard types have properties, initializers, and methods. They can also conform to protocols and be extended. Finally, a key feature of Swift is optionals. An optional allows you to store either a value of particular type or no value at all. You will learn more about optionals and their role in Swift later in this chapter. Using standard types. In this section, you are going to experiment with standard types in an Xcode playground, which lets you write code and see the results without override of manually running an application. In Xcode, select File, New, and Playground. You can accept the default name for this file. Make sure the platform is iOS. Click Next and save this file in a convenient place. The playground compiles and executes your code after every line and shows the result in the sidebar. In the example code, the var keyword denotes a variable, so the value of the str can be changed from its initial value. Type in the code below to change its value for str, and you will see the results appear in the sidebar to the right. The let keyword denotes a constant value. In your Swift code, you should use let unless you expect the value will need to change, because const str is a const. Attempting to change its value will cause an error. An error in the playground code will prevent you from seeing any future results in the sidebar, so you usually want to address it right away. In form types, at this point, you may have noticed that neither the const nor the str variable has a specified type. This does not mean they are untyped. Instead, the compiler infers their types from the initial values. This is called type inference. You can find out what types were inferred using Xcode's quick help. Specifying types. If a constant or variable does not have an initial value, or if you want to ensure that it is a certain type, you can specify the type in the declaration. Add more variables with specified types. Note that the sidebar does not report any results because these variables do not yet have values. The most common type for integers is int. For floating point numbers, Swift provides three types with different levels of precision. Float for 32-bit numbers, double for 64-bit numbers, and float 80 for 80-bit numbers. A Boolean number is expressed in Swift using the type bool. A bool's value is either true or false. The Swift standard library offers three collections: arrays, dictionaries, and sets. An array is an ordered collection of elements. Arrays can contain elements of any type, a standard type, a structure, or a class, and arrays are strongly typed. You can declare arrays in two ways. The second one is a shorthand syntax. Once you declare an array as containing elements of, for example, int, you cannot add a string to it. A dictionary is an unordered collection of key-value pairs. The values can be of any type, including structures and classes. The keys can be of any type as well, but they must be unique and hashable. Basic Swift types such as int, float, character, and string are all hashable. A set is an unordered collection, and its number must be unique. Sets do not have a shorthand syntax. Literals and subscripting. Standard types can be assigned literal values or literals. Let's run this code and see the results. Arrays and dictionaries can also be assigned literal values. Swift also provides subscripting as shorthand for accessing arrays. To retrieve an element in an array, you provide the element's index in square brackets after the array name. Notice that index 1 retrieves the second element. The array's index always starts at 0. When subscripting an array, be sure that you are using a valid index. Attempting to access an out-of-bounds index results in a trap. A trap is a runtime error that stops the program before it gets into an unknown state. Subscripting also works with dictionaries. More on that later in this chapter. Initializers. You can create a new instance using an initializer. You use the type name followed by a pair of parentheses and, if required, arguments. For example, to create a set, you can use the set initializer that accepts an array literal. Properties. A property is a value associated with an instance of a type. For example, array has a property count, which is the number of elements in the array as an int. Set also has this property, which records the number of elements in this set. Instance methods. An instance method is a function that specifies a particular type and can be called on an instance of that type. Try out the append instance method from the array. The append method accepts an element of the array's type and adds it to the end of the array. Optionals. Swift types can be optional, which is indicated by appending question mark to a type name. An optional lets you express the possibility that a variable may not store a value at all. The value of an optional will either be an instance of the specified type or nil. Recall that subscripting an array beyond its bounds causes a trap. Dictionaries are different. The result of subscripting a dictionary is an optional. If the key is not in the dictionary, the result will be nil. As with other optionals, it is common to use if-let when subscripting a dictionary. Throughout this course, you will have many chances to use optionals. The details of optionals will be explained in later chapters. Going through the motions is enough for now. Loops and string interpolation. Swift has all the control flow statements that you may be familiar with from other languages. If else, while, for, and switch. Swift does not have the traditional C type for loop that you might be accustomed to. You can accomplish the same thing a little more clearly using Swift's range type and the for-in statement. Did you notice that curious markup in the string literal? That is Swift's string interpolation. Expressions enclosed between parentheses, beginning with a backslash, are evaluated and inserted into a string at runtime. The most direct route would be to enumerate the items in the array themselves. What if you wanted the index of each item in the array? Swift's enumerated function returns a sequence of integers and values from its argument. The enumerated function returns a sequence of tuples. A tuple is an ordered grouping of values similar to an array, except each member may have a distinct type. Another application of tuples is in enumerating the contents of a dictionary. This code shows how to traverse a dictionary. Let's run this code and see the results. By clicking this button, you can see the value of the items in for loop. Enumerations and switch statement. An enumeration is a type with a discrete set of values. You can define a pi-type enum like this. Swift has a powerful Swift statement that, among other things, is great for matching on enum values. The cases for a switch statement must be exhaustive. Each possible value of the switch expression must be accounted for, whether explicitly or via a default case. Switch statements can match many types, even ranges. The case 0 to 8 is a range of int values. This case can be matched if macOS version is between 0 and 8 and contains 0 and 8. The other cases that are not in case list will be matched by the default case. Enumerations and raw values. Swift enums can have raw values associated with their cases. With the type specified, you can ask in an instance of pi-type for its raw value and then initialize the enum type with that value. This returns an optional, since the raw value may not correspond with an actual case of the enum, so it is a great candidate for optional bounding. The raw value for an enum is often int, but it can be any integer or floating point number type as well as string and character type. When the raw value is an integer type, the values automatically increase if no explicit value is given. For pi-type, only the apple case is given an explicit value. The values for cherry and pecan are automatically assigned a raw value of 1 and 2 respectively. Each case of an enumeration can have associated values. You will learn more about associated values in later chapters. Congratulations! You have become a junior Swift programmer. See you!